everybody. Hello, everybody. It's Mrs. Pound, and we are working on Chapter 1.3, talking about atomic structure. We are still in Section 1.32 about the structure of the atom, and I wanted to add a little subtopic here so that the videos didn't get too long. And the subtopic is about calculating atomic weight. Remember, we said atomic weight is not a whole number. Atomic mass is because it's counting the number of protons and neutrons in the nucleus of an atom. It's just adding those two numbers together. But the atomic weight has to do with the fact that there are different isotopes of the atoms of an element. And so they have different atomic masses, and we said that we take a look, we do a weighted average for these. So I'm going to teach you how to do that. So here is what a problem might look like. It says lithium-6 accounts for 7.59% of all naturally occurring lithium atoms. Lithium-7 accounts for 92.41% of lithium atoms. What is the atomic weight of lithium? Well, there's a few steps we have to follow. Step 1 is to determine the percent abundance for each isotope. So I highlighted those in the problem. We know that their percent abundance for lithium-6 is 7.59%, and the percent abundance of lithium-7 is 92.41%. So write that down on your sheet for that step, just like I have here. Step 2 is to multiply the atomic mass of each isotope by the percentage abundance. Remember to convert each percent to a decimal. So this is like money. If I say I gave you 92 cents, you would write that as a decimal as 0.92. Okay? So I did that here. I took the atomic mass, which is 6 grams for lithium-6, and that comes from the 6 behind the lithium here. I multiplied that by 0.0759 because, just kind of simplifying it, if I gave you 7 cents, I would write it as 0.07 and then add on the other numbers. And so when I multiply those two numbers together, I get 0.4554 grams. Now, for the lithium-7, I get the 7 grams from here, the fact that it's lithium-7, that's the atomic mass. I multiply that by 0.9241, again, just rounding it off a bit, getting rid of the decimal at the end. If I gave you 92 cents, we would write that as 0.92 and then just tack on the other numbers. And when I multiply those two numbers together, I get 6.4687 grams. And what I'm doing here is go ahead and keep 4 decimal places like I have in these numbers. Step 3 is to add each mass to determine the atomic weight. So I take those numbers that I found in the last step, 0.454 grams and 6.4687 grams, I add them together and I get 6.9141 grams. Make sure you're writing these down in the spaces. Step 4 is to check the solution to make sure that the answer makes sense. The atomic weight should be close in value to the atomic mass of the most abundant isotope. So when I check my answer, the calculated atomic weight of 6.19141 grams is close to 7 grams, which is the atomic mass of the most prevalent isotope. If my answer was way bigger or way lower, I would know that I did something wrong. So that is it. Those are the steps to follow to do these problems. So flip your page over, and there is a problem for chlorine that I would like you to try to do, and we will go over the answer together in class.